Welcome to the jungle, right? This is a little safari through the JVM landscape. I don't talk about any ChatGPT or AI stuff or the latest features. I don't, right? So this is just facts. It took me some time to put all these things together, and I hope I can educate you a little bit in terms of JVMs and OpenJDK distributions and all these kinds of things. So my name is Gerrit Grunwald. I'm working for AZUL as a senior developer advocate. I'm running a Java user group. That's my third time here at Devoxx UK, and I hope you had a great conference so far. You can follow me on Twitter if you like, and if you have any questions, this is the only way you can reach me where I really answer is Twitter. And I hope it will stay. If not, I will go to Mastodon. So, yeah. The slides you can find here, but be aware it's not the slides that I will show you because I changed it 20 minutes ago. So this is how it works, but they are close to this version. So every version is a little bit different. Just be aware of that. So otherwise, if you can't really scan it now, just come to me. I will give you the link. It's on SlideShare. OpenJDK. So my first question to you, and you listen to the question, who is running OpenJDK? You are wrong. Sorry. Because you don't run OpenJDK. You run a build of OpenJDK. And this is usually a distribution, which has a name and a vendor, right? So there's a difference here, because this is the problem. People approach us at the booth. I ask, oh, what version of Java do you use? Oh, I use OpenJDK. Sure, everybody uses OpenJDK. So which distribution? Oh, I have no idea. Okay, good. So this session is to give you an idea what's out there and where the differences and features and stuff. So OpenJDK is a free and open source implementation of the Java SE Platform Standard Edition. That's the definition, Java SE. And there's a website where you can find information about it, which is https://openjdk.org. Don't expect too many information there, but it's there. And then there's also the source code available for OpenJDK, and I think it was since JDK 16, it's on GitHub. You can find it here, github.com/openjdk/jdk. So if you're interested in seeing the source code of Java, you can look it up here. But be aware it's complex. Okay. It's open source. That means there are contributors, and this is the list of contributors to OpenJDK. And these are many more. And I put them under many individuals because they're even single person who really contribute to the JDK, but you also see big companies like Red Hat or like Microsoft, like AZUL, like IBM and others, Google and so on. They commit code to OpenJDK, which is a good sign, right? So if you bet on OpenJDK distributions, means it's not a one-man show, which is great, because if it would be a one-man show, you would rely on this one man. You don't do. There's a lot of companies that have interest in Java. They contribute to this project, which is good. Okay? It comes with a roadmap, and I give you, first of all, I'll give you some introduction in the whole OpenJDK thing. So this is the old release cadence. Who remembers JDK 6 in the audience? Oh, this is good. A lot of old people here. So who's running on Java 6 in production? Nobody? Okay, that's a good sign. 7? 8. Ah, that's okay. Let's say 11. Who's on 17? Someone above 17? Oh, the fearless people. Awesome. That's cool. So we see it was between 6 and 7, 4.5 years. Oops. Then 7 to 8, 3 years. And if you a little bit older, you remember these days, and it means you have to wait multiple years before you can test a new JDK, and you never know what's coming, because they came out with something like, oh, wow, that's cool features, and was lots of features in each release, which is, it was not really satisfying all the time. These days, we have this kind of release cadence, and you see it's a lot of releases coming out. And the pink ones is the so-called LTS releases. I will come to that, what it means. It means long-term support version. And they started with 3 years, now it's 2 years cycle, which is great. So that means in the meantime, now you can test a new JDK every 6 months, which is cool, because you can test new features very early and make sure that with the next LTS, it will work. Your software will work, so you can step up. In the past, sometimes it took forever to switch from 6 to 7, 7 to 8, right? 8 to 11, just to make sure that every new feature will work with your application. Okay. The heart of the whole OpenJDK thing is the JVM, the Java Virtual Machine. And we have to dig a little bit into it, just tiny little bit. So it has 3 big blocks, right? The class loader subsystem, JVM memory, execution engine. And all of these blocks, again, come with different parts like the bootstrap class loaders, extension, and so on, linking, and then initialization. This is the class loader subsystem. Then JVM memory has different parts like method area, heap, stack, PC register, some native method stack. And then there is the execution engine. And the execution engine comes with the interpreter, with the C1 and C2 compiler. It has a profiler. It has all the garbage collectors in there. And then there's native method interface, so JNI, and the native method libraries. The execution engine, we will come to that a little bit later, because there's something special in there related to OpenJDK distributions. But this is how it looks like. It's a quite complex thing. It's not that easy, right? And that means this is an abstract computing machine. That's what it is. Okay, that's just the basics. And we continue with the basics. JDK, JRE, you all know that. It's a Java development kit. It's a Java runtime environment. And the difference is that, because not everybody knows that, in the JRE, it's just the virtual machine and the class libraries, everything you need to run your application. And then the JDK is a superset, and it contains the JRE plus the Java C compiler, the debugger, and the Java docs. So it contains everything you need to develop applications, right? That's the difference. If you run a JDK in production in a microservice, you better run a JRE because it's smaller, right? This is the main reason for JRE is have a runtime, right? So the recommendation is if you're below JDK 9, so everything up to JDK 8, you should run development, of course, JDK, and in production, the JRE. If you above JDK 8, so 9 and upwards, you should use JLink. Who's using JLink? 1, 2. And the rest is using what? JREs? Yeah, okay. Just be aware that not every distribution will give you a JRE in the future, right? So you will only find JDKs because the preferred way to go is using JLink to create a custom Java runtime image that only contains the modules that you need. And there's a reason for that. First of all, it's smaller. Second part is the less you have in your JDK or in the JRE, right, the less vulnerabilities or attack vectors you open to hackers. Because if you don't use anything like XML stuff, then it's not in the JDK. So it's not hackable, right? So there's a good reason to use JLink. So that's the recommendation. If you run 9 and upwards, just try JLink. It's not that hard to use, and it really creates Java runtimes that you need for your use case. It's a good idea to use it. And then we come to this point, which is the most important thing. We have distributions. I told you already, these are builds of OpenJDK. And we start with these builds of OpenJDK because there's also another thing I will mention pretty soon. So we have this distribution. That's a number of distributions that I found that make sense. There are more, but some of them just have 5 packages, 10. So I don't really put everything in here. This is the list of OpenJDK builds that have at least, let's say, 50 different packages. And a package, I mean, it's something like a tar.zg file, a zip file, something like that, okay? And not only for one version, but maybe for a couple of different JDK versions. You see 2 of those have this little cross there, adopt OpenJDK. Who's using adopt OpenJDK still? Yes, 1 hand, 2 hand. Why do you use that? This is dead. It's officially dead. Just keep that in mind. It died with 1602. After that, there was the new project, which is Adoptium Tamarin, which is a different distribution. It's not the same, right? Just keep that in mind. Now it's an Eclipse project. Adopt OpenJDK was a different one. It's not the same distribution. So OJDK build, that was the community build of the Red Hat JDK version, and they stopped it with 17 or something. I can't really remember, 1706 maybe. And they officially said we don't do it anymore. The reason is, I guess, that Red Hat now uses Tamarin as the default. So that's the reason why there is no need to have a community build of the Red Hat JDK anymore. But then there are things like DRAGONWELL. Probably people heard about that. It's from ALIBABA, which is huge in China. But there are other things like Bisheng. This is Huawei. You might think, I never heard of it. It's huge. It's really huge. Kona is from Tencent. It's also from China. This is big stuff. Who knows Kona? Nobody. Who uses it? Nobody. Here. In China, lots of people use that. That's one of the reasons why I put it on the list. So it's really, and they have interesting features. We will see that later on. So then we have stuff like SEMERU. I have it 2 times on the list because there's a certified version and there's a community version, and there's a difference there. I will tell you later what it is. And then we have stuff like Oracle OpenJDK. And this is sometimes what people mean when they say, I use OpenJDK. Who's using Oracle here, by the way? Oracle Java FE SE subscription? I saw a hand there. No? Okay. There are free builds from it's called Oracle OpenJDK, and they only provide you, I think it's, if you have 16, then it's 16.01, 16.02, and that's it. And then they start with the next version. So you can download it for some time. There's not really a support for that, so it's just a build of the OpenJDK source code. Okay, so we have 20 different distributions. The question is, oh, I forgot, we also have build of GraalVM. Who's using GraalVM here? In production? Native image? Okay, cool, 1, okay. So this is another project, comes from Oracle Labs. And the main idea why they started it was the C2 compiler in the OpenJDK source code is so complex and old. It was started by Sun. They had the idea, if we rewrite the compiler using Java itself, and then we compile it with a native image kit to a native binary, we can use that one. It's easier to maintain. That was the main starting point way back in the past. It's open source, the community edition, and then there's something like Glue on GraalVM, which uses that. They add some stuff for doing it on mobile. Then we have the Liberica native image kit, which is from Bellsoft, and Mandrel, which is the Red Hat build of GraalVM. So this is not really OpenJDK, but I put it in the list because people use that, right? Okay. The question is which one to choose, right? What is the right JDK that I should use? Which is the right distribution to use? Not an easy choice. And there are some differences, and I try to explain with this list now where are the differences and what could make a difference. So first of all, there's the term of support. I will explain that later on. Update strategy for all the distributions. Compliance. Then there's cost, of course. It's not everything is for free. Performance. This is something people are really interested in, and you will see it's a really big difference there. And features, right? Because it's all builds of OpenJDK doesn't mean it's all the same. Okay. So let's start with term of support. What do I mean with that? STS, short-term support version. This is something like 15, 14, 13, 16. Everything that is not a long-term support version is a short-term, which is called STS. That's just a shortcut for it. And there's LTS, long-term support version, right? And you might ask yourself, okay, yeah, that's interesting, but I don't really need that kind of information. Well, let me give you a little overview how it works. So this is all the different versions that we have from JDK 9 on. And all the white ones are the STS releases, and we only have them for 6 months. So if you come out, if, for example, 10 comes out, 6 months later is 11, and that's it with 10. No support. Game over. If you go to 12, and that was the big problem here, that was the 3 years between them in the beginning. Let's say you start with 12, and with 12 there was something introduced called like JPackage. Makes it possible to create a native package for an installer, right? For your Java application, for example. If you use that and you stick to JDK 12, that means 6 months later there's JDK 13. If there now is a security patch for 13, there's no backport to 12. So you stick with the security issue in 12. And that goes on. 6 months later, there's 14, and there's 15, and there's 16, and then there's finally 17. And then you can go to the next long-term support version. Long-term support means really long-term, not 6 months. This is years of support that you can get, right? This is the difference. And this is also the reason why these long-term support versions make some sense to use that in production. For development, you can stick to the STS versions, but for production, I wouldn't do that. That means short-term support, only 6 months. After that, it's up to you. Then it means if there are security issues in the upcoming versions, you always have to update to the next one. This is the only way to really make sure it's safe. And then not every distribution provides a short-term support version and a long-term support versions. There are distributions, they say, no, we only do long-term support. So that means if you, for example, if I'm right, it's DRAGONWELL from ALIBABA, you will only find 8, 11, 17, and there will be 21. All the features in between you can't test with these distributions because they don't deliver an STS version. They only have LTS. So it's like in the old days. You have to wait years to get the new features, right? So you have to keep that in mind if you're really looking for a new JDK distribution. Recommendation in development doesn't really matter, but in production, stick to the LTS versions. Do yourself a favor because this is really supported stuff on the long term. You can test things in development using STS, but in production, you would like to make the safest thing possible, and this is using LTS releases because they get updates over the years. All right, that leads me to updates, because this is something else which is not really well known. We have so-called critical patch updates. Who knows that? 1, 2, 3, okay. And then we have so-called patch set updates. Does someone know what it is? And that's what I thought. Most of the people never heard of it. The reason for that is that you only get this usually. And then there's no reason to name it, right? So the CPU, the critical patch update, only contains fixes for vulnerabilities and critical issues, and that's it. Nothing more. Where the PSU is a superset, that means it contains the CPU, but it also introduces fixes for non-critical issues, and it can contain new features. That means it can introduce new issues. You can imagine if I introduce a new feature in a release, and then people start using it, they might run into problems with these new features. So that means there could be new security issues. And that's, if you remember JDK 8 from Oracle, then they had these versions like 8.0251, 8.0252. And people ask themselves, what is it? And this is CPU PSU. That was the reason. The one only contains the security fixes. The other also has additional features and non-critical fixes. So these days, only a couple of distributions offer both of those, but we will come to that. So we'll have 4 times a year, we will have these updates. And to give you an idea how it works is, let's say in January, we start with 1701. On the top one, you see the PSU that contains the CPU, plus additional stuff. And on the bottom, you just see this is just the CPU, just the critical fixes. So then in April, the next update will come out, 1702, and then it works like that. On the upper part, we introduce fixes and new features, but the 1702 only contains the bug fixes from the 1701 PSU to make sure that you get the features from the last version, but now with the fixes, right? That means the CPU is always the safest thing you can get if you run in production. And this goes on then July, the next one, and then October, the last one. So the problem is now patch set updates, so the one that contains also new features, that are available from all of the distributions. So if you download something, let's say Adoptium Tamarin, it's only PSU. There's no CPU from that distribution. If you would like to have a critical patch update, then there are only these 3 companies that offer that. And this is not for free. You only get that if you have a service contract. Because for these companies, of course, that means they have to create a separate version. They have to test it and all these things, right? And they only have the bug fixes and really the vulnerabilities fixes and stuff like that. So this is the CPU updates. And that's the reason why you don't find them on the websites, because you have to pay for it. And that's why people don't know CPU, PSU, because they only get the PSU for free. Okay, so if you read in the future something like CPU, you know, this is just the safe thing, and the other one is including new features. The recommendation, again, of course, if you run mission-critical stuff in production, you would like to run on a CPU release to make sure that you have no vulnerabilities in there. In development, you can use whatever you like, of course. And then this is one of the reasons why this is important. We have compliance, right? And we have different things there. There's the so-called TCK. Did someone ever heard about that? Yeah, I guess that's a lot of people heard it somewhere. Technology Compatibility Kit. That's the translation. It's licensed by Oracle. It was originally developed by Sun Microsystems, and now it's the intellectual property licensed by Oracle. And it contains, for example, more than 120,000 tests just for JDK 11, right? And this is really, and we come to that, one thing that is important to know, any binary that will be created, that means if it's a zip, a MSI, an exe file, a package, DMG, whatever, every package has to be tested against the TCK. You can't really test against the TCK because what it's really going on is it's the so-called JCK, right? To make it more complex, of course. This is the Java compatibility kit. This is really the tests inside of the TCK, right? That's the reason why I mentioned that. People mostly, sometimes you find a distribution, they say, oh, we are compliant to the JCK. You say, oh, JCK, never heard of it. So it's a part of the TCK. You just have to keep that in mind. This is the important part. So, and it tests features that are likely to differ across implementations. They rely on hardware or operating system specific behavior. So this is the actual tests. And if you take a look at the code, you can get the code from the JCK. If you take a look at the code, it's so complex. They really test the API, the implementation in Java, everything is tested. So it's really fascinating to see, and it's a lot of tests. Things that are difficult to port, either mask abstract hardware behavior or whatever. So for example, to run the JCK, you need to connect the computer to a printer. That's very important. You need to have a sound card in there. It's part of the JCK. So you can imagine if you have to do that for all the different platforms, the different hardware platforms, you need to have the hardware, you need to run the tests on the operating systems and all these things. It takes us weeks to do all these tests for every release. So it's quite complex. How to get access to the JCK? Because I said you can look up the code. It's not that hard. It's available at no charge. You have to fill out a lot of paper stuff to do it. And you have to meet the terms of the OCTLA. And I always have to read it. It's the Open JDK Community TCK License Agreement. Nice. If you meet these terms, fine. You can take the Open JDK source code. You can apply for the TCK or JCK in this case, and then you can build your own JDK if you like. But that means you have to run all these tests, which is really, you don't want to go there. And you also have to sign the OCA, the Oracle Contributor Agreement. I told you already that there is, for example, IBM SEMERU, which is the OpenJ9 JVM. Who's using that? Someone in the audience? Oh, it's not a bad JVM. It's not really based on OpenJDK, which is the problem, because they have, I told you, they have a certified version and they have a community version. IBM is, to my knowledge, the only company you have to pay for the TCK, because Oracle said, you know what, this is not really based on OpenJDK. If you would like to have the TCK compliant, you have to pay. That's the reason why you have to pay for the SEMERU certified version, because this is TCK license or TCK compliant. And the community edition is not. So that's the reason why it's free. And then the next thing is, just because a distribution says, oh, we are TCK compliant, doesn't mean all the versions are TCK compliant. For example, this is the list of distributions that are TCK compliant for JDK 8. And you see there's DRAGONWELL in here, which is, okay, fine, right? And you also see it's not 20. Not all of them have the TCK compliance. You might think, oh, I don't care. Well, that makes sure that everything in Java works as expected. Means if some of these distributions fail the TCK test, that means you can run into that problem in production. So it's a good idea to have a distribution that is TCK tested. So back to this one. JDK 8, you see DRAGONWELL. JDK 11, for example, because DRAGONWELL don't have 9, in JDK 11 there is no DRAGONWELL TCK because they introduced something which breaks the TCK test, so they can't get it. But on the website they say, oh, we are TCK compliant. So you have to be careful with all these things, right? So, and there's a list where you can look it up, which distribution is compliant to the TCK and which is not. So DRAGONWELL, for example, is not for JDK 11 and 17. So that's the reason why they don't have it. Okay, and like I said, sometimes you find something like, oh, we are JCK compliant, which is also okay. It's part of the TCK. Okay, but you see most of them are TCK compliant, which is good. That means you can exchange them without any problem. It will work, right? That's the main idea behind the TCK stuff. Then there is another one called Aquavit, and it's not the drink. It's the Adoptium Quality Assurance Vitality and Speed Test Suite. Oh, I love these long names. It's by Eclipse. It came when Adoptium started. And one of the reasons why we have Adoptium Tamarin is that it was Adopt OpenJDK, and Oracle said, nah, you know, you have OpenJDK in the name, and this is our trademark. So they are not really happy about that. That was one of the reasons why Adopt OpenJDK was not TCK compliant, because Oracle didn't like it. So they had to change it, and that's the reason why they went to Eclipse, and then Eclipse Foundation decided, oh, it might be a good idea to have another test, which is the Aquavit test suite. And this one, compared to the TCK, makes sure that it's on application level and use case level, everything's fine, right? So they have, I think it's more than 350,000 tests they run, and they try to run stuff like really real-world utilization patterns, and they run it on your JDK distribution to make sure everything is as expected. And this is quite new because it's only available since, I think, 2 years, maybe. And yeah, it's a suite for security and durability tests. These are the distributions that are compliant to the Aquavit thing. And another thing is, if you are compliant to Aquavit, you also have to be compliant to the TCK. So that means if you only see this one, it means they also have the TCK. But again, DRAGONWELL, only JDK 8. Right? So this is, it's complex sometimes. And you can get that on the Adopt Your Marketplace page, these JDKs. Okay, so recommendation, development, I don't care. Production, make sure it's a TCK compliant JDK distribution, which are most of them, but you have to know that this is available. Cost, yeah, that's an interesting point. Who's paying for Java here in the room? I mean, for service and support. Yeah, that's what I thought. We are so used to use the free stuff, right? It's so cool. Yeah, I love it. Yeah, we have free distributions out there, and these are the stuff that is free. And you see, it's nearly everything is free, which is awesome. And of course, there's also stuff that is not for free, where you have to pay for, and there's a reason for it. First of all, it's one of our own JVMs, which is called Platform Prime. And I will give you some information later what the differences are, but you have to pay for that one. And the costs are based on the number of vCores in the end. Then there's IBM SEMERU. I told you the reason, because they have to pay for the TCK. So you have to pay for that. Then there's GraalVM Enterprise, and you have to pay also for the number of cores. And there's Oracle JDK, where you have to pay for. This is the Oracle Java SE subscription model. Well, Oracle did a nice thing in January. They changed that, right? I don't know if you can read it, but they changed it from the number of vCores to the number of employees. That's a smart move. And they did not only do that for you, but also for your third-party companies that deliver stuff for you. So let's say I'm Volkswagen. I have 1,000 developers using JDK. I pay for 1,000 vCores. Now, I have to pay for the number of employees of Volkswagen, which might be in the 200,000, I don't know. And because I have companies like Bosch, which is also big, oh, we also have to pay for this number of employees, right? So you can imagine that's a huge number you have to pay for. So if you have a Java SE subscription with Oracle, you better watch out about the pricing stuff, because it also applies, even if you have an old contract, if you change something, one new developer, you apply to the new one. and then you have to pay for all your people in the company. If they use Java or not, it doesn't matter, right? Just be aware. And it includes GraalVM Enterprise. So things you have to know. Leads me to performance. And this is the stuff everybody's keen on, right? Yeah, it's so crazy. We have baseline performance. This is all the same. Awesome, right? Because it's based on OpenJDK, most of the stuff, it's the same source code. So why should it be faster than the other? Some of them might be faster, right? A little bit. You see SEMERU here. I told you it's not really based on OpenJDK. And you also, I have GraalVM here, which is also not really based on OpenJDK. But still, the differences, and I don't talk about GraalVM native image because the performance is really bad. If you do that, if you run GraalVM native image community edition, which is the free one, that's the one that you get with Spring Boot and Quarkus. Do yourself a favor, run the same thing on the JVM and run it as a native image and compare not the startup time, but the performance. There's a nice blog post on beldung.com where they did this comparison, and you saw a drop in 50% of GraalVM native image. Yes, it starts up very fast, but then it's very slow. Right? Just keep that in mind. If you hear GraalVM native image, it's so fast, it's usually when they talk about the enterprise edition, which is much better. But the community edition, it's really slower. So, but these things more or less are all at the same level. There's not a big difference, especially if it's a build of OpenJDK, it's the same performance, more or less. Might be milliseconds different, but not really huge things, right? Then we have, like I said, it's more or less the same, with some exceptions. Like, for example, the SEMERU stuff has a faster startup, lower memory footprint. Performance can be a little bit better, but it doesn't have to be. Then we have high performance stuff. And then for this one, I have to give you a little idea why this is different. So I told you already, we have these 3 blocks in the JVM, and we have the execution engine. If we take a closer look, we see there's the JIT compiler part and there's the garbage collector part. And you can replace that. And it can still be TCK compliant, right? So that means you can take out the JIT compiler and take another one. It's more or less that what GraalVM is doing. You can also exchange the garbage collector if you like, right? It's possible. So we do exactly that, and that's the reason why you have to pay for Prime. We developed our own compiler, which is a LLVM-based compiler, and this is just faster than the C2 compiler in OpenJDK. And in addition to that, we also added our own garbage collector, which is pauseless and can handle heaps like up to 20 terabyte. So we have a customer that has a 20 terabyte heap with no garbage collection pauses. So this is the reason why you have to pay for that, because we spent some time on creating that stuff. Then there's GraalVM Enterprise, and the Enterprise thing is really fast. This is good stuff, but you have to pay for it. Remember, it was this employee-based license, right? And I think that's more or less it if you go for high-performance applications. So what do I mean with high performance? If you do high-speed trading, right, you can't really use any garbage collection pause there because every millisecond counts. That's the reason why, for example, Prime is used in all these banking stuff, high-speed trading, online gaming, for example, because you don't want to have a game and then suddenly it doesn't move. Oh, it moves. Oh, I'm dead. Great, right? So you don't want to have that. So this is the reason why we have these 2 things. GraalVM also produces quite fast code, the Enterprise Edition. All right. Keep in mind, the faster the JVM, it can reduce cost. If the JVM can produce the same, or let's say, you can solve the same problem, but don't use as many cores to do that, you can save really money in the cloud. Right. Now, this is the interesting part, really interesting part, because even if these are all builds of OpenJDK, every vendor can add some additional features to the JVM. They just have to make sure it's TCK compliant, but they can add whatever, right? So, and I will give you a little overview. First of all, there's Amazon Corretto. Who's using that? I guess with Lambdas? Snapstart is the new hot thing. And it's based on a technology called Crack that we invented, by the way, and Firecracker. And yeah, it comes, I think, since The day before yesterday, it's also available for Java 17. Before that, it was only Corrado 11. Now it's also Corrado 17, where they have the support for this one. And that makes it special because not every JDK has this feature. Then we have ALIBABA DRAGONWELL. I mentioned that a couple of times. And they have a standard and an extended edition, and they have something called JWarmup. And what they do is they have an experimental faster startup by caching compiler optimizations. Well, that's a nice idea that also we invented 10 years ago. And then we started using the OpenJDK source code. And then at one point we figured out we can't really do what we like to do, and we created our own compiler. And this is based on the stuff that we did in the OpenJDK source code. So, and this is also the reason why they don't get the TCK, because this one breaks tests. This is one of the reasons why we created our own compiler and added it there and make it work with the TCK. Then they have something called Elastic Heap, which is a GC feature that returns memory to the operating system. WISP2, a stackful symmetric coroutine at JVM level. These are all things that they use on the Alibaba cloud, which is similar to AWS. And it's huge in China, even if we don't use it here. So then we have Tencent Kona. I also mentioned that already, again from China. They are specialized on ARM. Is someone doing here embedded, Java on embedded, automotive? Yeah, so in automotive you find a lot of ARM stuff and also Java, believe it or not. I know that on the Volkswagen ID 3, 4, and 5 models, for example, they have at least 3 installations of our AZUL ZULU running in the car. So it's interesting that Java is really everywhere. But Tencent Kona is specialized on ARM, so they have something which is really interesting. They have Kona fibers, and this is Loom, but they did it in their own way, and they also say it's faster than Loom, and they have it for JDK 8 and 11 on ARM. And that's interesting. So you see, they're not really stepping behind. They are in the front row, playing with the big ones, but we never heard of it. Did someone hear about Kona fibers? I guess not. It's out there for more than a year, and they have it already in JDK 8 and 11. They also added ZGC for ARM, right? Because they rely on this, because they run on embedded stuff. So it's really, Tencent Kona is big, and they have some nice features, and it's worth trying it. They have some benchmarks on their website for this Loom versus fibers, and they show that fibers are faster than Loom. So it's really interesting. Then we have Bells of Liberica. Who's using that? Nobody, okay? They have JavaFX, for example, which makes it a little bit special because it's one of the distributions that you can get with JavaFX bundled, like it was in the past when it was in the Oracle JDK distribution. It's not part of the JDK, but it comes bundled with the JDK. And that makes it a little bit special here. Then we have Bells of Liberica NIC, which is the native image kit. This is the GraalVM version. And this one also comes with JavaFX. And this is something interesting. If you are into JavaFX and you would like to create native images for desktop, go here, because you can directly do it. You don't have to install OpenJFX and do all this hassle, right? Then we have Oracle GraalVM, which is, of course, a little bit special because it has a community and enterprise edition. It has a polyglot VM, can run Java, JavaScript, Python, R, and Ruby. And it has a GraalJIT compiler, which is this replacement for the C2 compiler, written in Java. And they have a Graal AOT compiler. This is the thing that creates a native image, right, for you, ahead of time compilation. Then we have IBM SEMERU. Already talked about that one. It has also community and certified edition. It's based on OpenJ9 or the J9 JVM, which is not OpenJDK. They did it from scratch. IBM wrote the complete JVM from scratch. And it has a faster startup. It has a lower memory consumption. It has lots of features, like, for example, they have an AOT compiler that can dynamically compile code, AOT code, right, to get a faster startup. They have Instant On, which is similar to Crack. Who heard about Crack, by the way? Yes. So this is the same thing, but they name it Instant On. It's based on the same technology. They also have an API. We are in touch with them. So there's really no difference. It's just the stuff runs on OpenJ9. And they have a JIT server, which is that you take the JVM, install it somewhere on the server, and then you have microservices that ping that server, for example, and every time they ping it, it will compile the code from that service, and the next time you call it, you directly get the compiled code back. So you don't have to compile it on the service itself. So the optimizations are done on the server and keep on the server. But as far as I know, it's just one instance on the server, so it's not like a cluster. Okay, then we have AZUL ZULU, which is the one that we do. We also bundle JavaFX with the JVM. We have something called AZUL vulnerability detection. This is something which is only available here. What we do is, you can imagine, who's doing security testing? Like scanning, CI/CD scanning, something like that. You should do. I would see all the hands should be up. Who's using something running in production? Security scanning in production. 1, 2, yeah. That's exactly why we created that. Because usually what you have to do, you have to install an agent besides the JVM. And then the agent will call the JVM, and you have some kind of a callback. Every time the JVM is loading something, it calls the agent, and the agent then checks, oh, there's a vulnerability. That's how it works. It comes with an overhead of at least 10%. So what we figured out is, in principle, it's not needed, right? The JVM knows exactly what it's loading and where it is loading from. So what we did, we just added an additional tool, which is called forwarder. And then the JVM, just when it's loading stuff, from time to time, it tells the forwarder, oh, I loaded this stuff. And then the forwarder will just check against the web service and will check, oh, is it vulnerable code? And the advantage here is that we can tell you, oh, you have a dependency on log4j. Oh, by the way, this is vulnerable. We have CVEs, but you are safe because you never use it. The JVM doesn't load the code. And this is the advantage that we can do. Then we have crack. And it will be officially released in ZULU next week. So next week, there will be an officially supported version of ZULU that comes with crack. So you can use crack if you would like to. It's free. Just use it. If you run into trouble, contact us and we will try to fix it and help you. But we will come out with that version. This means coordinated restore checkpoint for those who never heard of it. You can think about if I just shut down my computer just by closing the lid and I reopen, it will reopen this slide in my application, right? We do the same on the JVM. You start it up, you run your program. At one point, you just stop it, save the whole state in a file, and then you can restore from there back to memory. Means we just restart the JVM. We don't have to go through interpretation and all that. It just continues running. And it gives you startup times up to or down to 30 milliseconds, 50 milliseconds. So we have some demos that are available where we, for example, run a Spring Boot application just on the JVM. It's 4 seconds. Using crack, it's 40 milliseconds, the startup, right? So it's interesting. Then we have Platform Prime, already mentioned that. We have a FalconJIT compiler, which is our own compiler as a replacement for C2. We have the C4 garbage collection, which is pauseless. Who knows the ZGC stuff? This is in principle exactly the same, just we did it 10 years ago. We have a patent on that one. So we do exactly what ZGC is now also doing. We have Ready Now, which is something like, you can think about, this is what the J warm-up stuff was in ALIBABA, DRAGONWELL. So our compiler compiles and optimizes the code. And every time he does it, we just save all the optimizations. And the next time you start your application, it just loads the file and tells the compiler, oh, you don't have to go through all this stuff. Just use this. This is the optimized version. This is how you should optimize the code. That saves a lot of time at startup to warm up the JVM. And, oh yeah, we also have, oh, this is not true anymore. It was called Cloud Native Compiler. Now it's Cloud Native Optimizer. So it's in principle the same thing that the IBM SEMERU is doing. But what we do, we put the JVM in a cluster where we have multiple of the compilers, and then you just forward the code to the compiler. It will be compiled once, and the next time you call it, you will directly get back the compiled code, the optimized code. So the cluster will keep all the optimizations and optimized code. And of course, this also comes with the AVD, AZUL vulnerability detection. And crack, yeah, it will also get crack. So we have all these features in there in the future. Right. So that leads me to the takeaway, and we still have 6 minutes to go. Not bad. Are all those builds of OpenJDK really different? You guess already, technically, no. It's more or less the same. When it comes to service support and costs, Probably yes. There's a difference between all these things. You saw that. We have in principle, it's the same performance. Some have different features that might be useful, like let's say Corretto for lambdas in AWS. Of course you use that because it solves the problem, right? And there are other things where you have to choose between these features. But from the pure base, it's the same thing. So that means you have to really choose wisely before you select a JDK. Just think about it, go through the stuff, and then make a wise decision. And with this, I say thank you for attending. And if you have questions, we still have 5 minutes. Otherwise, you can also come to the booth, and we can discuss there if you're too shy to ask now. But if you have questions, like I said, still 5 minutes left. Any question? Yes?
Can you sort out things? Thank you. Thanks for the presentation. About OpenG9, to my point of view, I am really not used with GDKs, and it's my source of information regarding the --XX options, and I'm always lost regarding those options. What is official, what is not, where to find the right information?
Yeah, that's really the biggest problem, because every JDK distribution, we also have for the prime JVM that I showed you, right? I don't know, we have a list with this, it's in the hundreds of switches that you can toggle. And I have no idea where to get the information. It's really hard, even for me, with our own JVM, it's hard to get the information because there's so many things you can tune, and J9 has the same. This is how it usually works. You have this -XX colon, and then you can do whatever feature. And then you pass it to the JVM and it does some magic. Unfortunately, there are some standard stuff that is in OpenJDK that's available everywhere, and there's a list on that. If you just look for this command line switches for the JVM, you will find a list. But just be aware it's a small list, because that's the stuff they share, and then they have lots of things that they don't share. It's unfortunately there's no list. Oh, I see there's a hand in the back. Is that a question, or is it a sign that I should stop talking? Okay.
Keep going. But there's a website called Chris Who Codes.
Yeah, that's right. That's right. He has a lot of information, Chris Who Codes. And it's also available via fuj.io, which is a website that we created. It's some kind of if you remember java.net in the past, and it went away because Oracle thought it doesn't make sense. We tried to create something like that, like a website where we collect all information related to Java, which is called fuj.io. And we also have stuff from Chris on that website. So there's a lot of information. That's true. There are the command line switches. There's a list of that. Thanks for the reminder. Yeah, good one. Another question? If not, then feel free to leave the room.